All right. Now that we've got our feet underneath us, we know how to move around in Comfy. We know what Comfy is. Now it's time to put Comfy to use. So, what we're going to be doing is we're going to be walking through a text to image workflow. I'm going to show you how to build it, how it's all structured, how the data moves through it. And then after that, we're going to take control even more beyond a prompt. And I'm going to show you how to use an image to image workflow. And it's very easy, just one little tweak, but it demonstrates a really core principle of controlling your images in Comfy. So let's dive in. So again, nothing more imposing than a blank canvas, right? Well, let's do something about that. Let's go ahead and drop in our checkpoint. And for this, we're going to be using Stable Diffusion 1.5, 1B5, whatever. But this is not, this is one of the kind of the core nodes of the core models from back in the day. There have been a lot more since this, but I think it's fun to start with this so you can kind of see where really how far we've come. And Stable Diffusion is still a great workflow to use. So a great model. So all we got to do now to start generating all of this is let's go ahead and bring in the other nodes that we need, which let's go ahead and clip text. We're going to need this for both a positive prompt, Control C, Control V, and our negative prompt. And this checkpoint, again, has this all bundled together in one model. This is common. Sometimes some models also have it separated out where you can take other clip models or other VAE models outside of this checkpoint and use this too. But for this demonstration, we're going to keep it nice and tidy and keep it all in here. So all we got to do here is take our clip, plug it into our clip, and take our clip and now plug it into our other clip. And let's go ahead and keep this nice and organized by let's go ahead and call this positive, and let's go ahead and call this negative. All right. I also love the reroute nodes right here. This again keeps things nice and tidy, fighting the spaghetti. So you'll see me use this often. I love right angles. It's my years of being a VFX compositor. So you're going to see me organize my comps very much like this. So next you're going to see we're going to need a KSampler node. So let's go ahead and bring that on in. Connect that there. And we're going to connect our conditioning from our positive into our positive input and our negative conditioning into our negative. And now let's go ahead and start connecting our model. And we're going to drag out the model tab and plug it right in there. And again, I'm going to add that reroute node, that little dot, bring that over there so we can see the flow nice and easy, right? And we have almost everything we need, except we're missing this latent image. So let's go ahead and empty latent image. Again, I'm just double clicking on my graph for whenever I want to bring this up. So you'll see me do that a lot. So get used to double clicking in graph. It's a good way to bring up the search bar really, really quick. But we now have our empty latent image here. And again, think of this like your canvas. This is the size of the image that we're going to be generating. So we go ahead and plug that in there. And then we're going to need our decode, right? Well, it's nice whenever we pull out of these the handles on the knob, it goes ahead and gives us a little suggestion of what it thinks we need. And we definitely need that VAE decode, because now we're going to take this image out of the latent space and we're going to be resolving it into RGB space. And in order to do that, it's going to need the VAE model. So this again is the part of the model that's used for encoding and decoding images from latent space. So it needs to know how to do that. So by connecting this VAE to this VAE input on the decode, well, we've now told it what information we need. Again, everything in a node graph is just information flowing from one place to another. It's like a big game of telephone where it's just passing everything along to the people that need to hear it, or in this case, the knobs that need the information. So now we have this over here, and we can basically just kind of keep. I think we're going to keep all of this the sampler the KSampler are all set to probably just these base values. But just to go over it real quick, we have our seed up here. So this is going to be the random string of numbers that is going to create the noise field of the latent image. So we can go ahead and just put in a 1, 2, 3, 4, 5, 6, 7, 8, 9. Steps, again, are the number of times we're letting the model denoise that image in order to resolve the final image. Every model is going to have its own magic number of how many steps is required to give that final image. So we're going to have it here at 20. That's pretty good for this stable diffusion model. And then CFG, again, this is the balance of creativity. We're trying to tell the model how much room it has to be creative or how closely we want it to stick to our text prompt that we're giving it. 8 is a good number for this model, but other models are different. And then we have our sampler, which this is the algorithm that is being used to actually denoise the image. So we're using Euler right here, but there are tons to explore. Some are more popular than the others, but I also really like the DP MPP underscore 2M. Rolls right off the tongue, doesn't it? that's pretty good for stable diffusion. So you can change that to that if you want to follow along, or keep it to Euler. It's fun to kind of compare which sampler you're going to be using, because again, that will affect the output of your image. So play around. And then we have our scheduler. So this, again, as it says here in the tooltip, controls how noise is gradually removed to form the image. This is telling it, this is a very simple scheduler right here. So this is going to start denoising right when we hit run, and it's going to stop right at the end. Other schedulers have different curves in time. If you think of it like a timeline, some of these will denoise from the beginning up until the middle and then stop, and then just kind of let it run after that. This will affect your final output. And so there's a bunch of different use cases, and that's why there's so many schedulers. But because we're doing an overview, I'm going to keep this simple. But that is that's going on. And then denoise strength is going to be the amount of denoising we want it to do. For a text to image workflow like we're doing here, keep this at 1. But I'll show you in just a little bit for that image to image workflow why you'd want to lower this down and what that actually does. So think of this, the denoise of 0 to 1. 1 is pure white. So if you think of this empty latent image as your canvas, this is like putting completely opaque white paint all over your canvas and preparing it for the model to paint the picture on top. But again, we'll talk more about that later. But keep that thought in your mind. It's the transparency of the prepared white canvas that we're going to make an image onto. And now that's everything that we need. And then we're going to hit our VAE decode, drag this out, and we're going to hit preview image. Drag this out again. I typically like to use a preview image instead of a save image right out of the gate, because again, I don't want to just keep generating more saved assets inside of my input folder or my asset library over here. So it's just a way to kind of keep experimenting and not get too bogged down with a whole bunch of images. So I'd recommend you do that there. But let's go ahead and let's just start with a simple thing. My daughter loves butterflies. So let's go ahead and type in butterfly for our positive. Our negative text, well, I don't want a low quality butterfly. I don't want a butterfly with any text in it. And I definitely don't want a butterfly with a watermark over it. So these are all the things I don't want to see. And my positive, of course, is what I do want to see. And it's all of this guidance right here is now going to flow in the KSampler. Again, then be decoded, and then we're going to see our image. And so I think we're ready. Let's go ahead and hit play right over here and see as it goes. It's loaded into the queue. And now we have a picture of a beautiful butterfly with a little suspect anatomy. but hey, this is where we started, right? But yeah, it's a nice butterfly. Looks good. So that is a basic text to image workflow. Now let's talk about a image to image workflow. And spoiler alert, it's very similar. It's not that different. The only difference is that again, instead of giving it a blank empty latent image, a blank canvas, well, we're going to give it essentially an underpainting, something to guide the final image generation. So since we're in the world of butterflies, let's go ahead and copy paste this in here, and we've got an actual butterfly here. Now, what I can do is I can now use this as my new empty latent image. But what happens if I drag this out and try to hook it into the latent image knob? Well, can't do it because we haven't converted this to latent space yet. So when we pull this out, well, you're going to have a few different suggestions here, but one of the third down that is what we're going to need is a VAE encode. So we are going to encode this latent image right down here with a resolution of 592 by 571. So different than our empty latent image, which was 512 by 512. And we're going to drag this over here on the dot node. If you hover close to it, you'll see we get little other dots on the side. Go ahead and click and drag that out and connect that into the VAE right there. Now we're going to be ready to then take this latent image over here and plug it right in to our latent image on the KSampler. And now let's go ahead and hit go and see what happens. Okay, we're starting to see more influence from this into our final composition over here because of our underlay. But what if we want to have more influence? Well, let's go ahead and lower this denoise value. Let's go down to 0.9. And to keep this test nice and accurate, we're also going to go up to the seed. And I'm going to click over here and I'm going to choose fixed value. And what that means is that every time I generate, I'm going to use the exact same seed, the exact same noise pattern to denoise in order to generate my image. This is a good way to kind of start locking in on a particular style or subject or just really anything, the result. Go ahead and lock that in, and we're going to keep everything else the same too. But now we have a denoise pattern of a denoise amount of 0.9. And different denoise values, as you can see here, will have different results over your final image. Typically, I find when I'm doing an image-to-image workflow, around 0.4 to 0.6. Again, I'm going to refer to it as transparency. It's not truly that, but it's the amount of that under image that's going to be visible through the noise pattern to the model. So think of it that way. 0.4 to 0.6 seems to be pretty good with most models. With Stable Diffusion, it's a little bit higher. It's around 0.8, 0.9. But let's go ahead and run this result. And let's see, again, what happens. We're playing around. Well, it looks like more of my colors actually came through here. More of that base shape, right? So if we want even more, and it looks like you even got an invented little tail down there, but it's being guided again by the pose-ish of the butterfly, the angle, the colors that it's seeing through there. I'm not prompting it for blue wings. It's inheriting that from the base image that I'm giving it. So we're going to say, I want you to inherit even more. So let's go down to 0.8 and click go again. And now you're going to see more and more of that base image start coming through. Let's keep going down and see where we go next. 0.7. All right, 0.6. I think we're in that kind of sweet spot. But what I'm demonstrating here is, again, that amount of noise that you give it shows how much of the base image that you see. And look, now we've lost that little tail, and we've got more of the wing pattern underneath there. So if I then go all the way down to 0, can you guess what's going to happen? Well, it's going to basically just take that empty latent image that we started with, that picture of the butterfly, and ignore everything else and just give it to me. Just give me an exact copy of it with the same resolution and everything. So that denoise value is really what is controlling all this stuff. Again, I think zero point 0.6 to zero point 0.8 is a pretty good zone. But again, play with these values. And as you can see here, I'm not chasing one image. I'm not going in and adjusting my prompt. I'm giving it a very basic subject that I want. I want a butterfly. And I'm generating takes, essentially. That's really kind of how I think about generating images with AI. It's more like film takes. It's sometimes going to give you not what you want, but also sometimes happy accidents. And sometimes it's going to get you exactly where you want it to go. So don't chase, just generate. And let's go ahead and play around now with the seed value so I can also show you. So this is another way to control your image. Again, we locked it down with the seed of 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I want you to go ahead and try some different seed values. So let's go ahead and take this seed value of 1729384. Now there's nothing special about this number. It's completely random. But let's go ahead and hit paste. And let's hit play and generate. Again, I haven't changed any other values. This was my image that I got with the denoise of 0.7. And let's go ahead and see it queue. And it looks like it's starting to hang a little bit. And this will sometimes happen in Comfy Cloud. So this is whenever this happens, just go ahead. I usually give it like a 10-second rule. And if it's stopped, I just click X. I'll go and click that out again and hit go again. And essentially what's happening is it's choosing a GPU to get processed under. So sometimes it hangs. Maybe that GPU is busy at the time. A variety of things could have happened. But just kill it, start it again. Again, give it that 10-second rule. All right, so now we have this image. And what we can do, all right, let's go ahead and actually, instead of using preview nodes, let's go ahead and drag this out. And I'm going to hit save image because I want to now start comparing the different seed values. And so we're going to load this all in the node graph. So let's go ahead and do this one more time. Save image, hit play. Again, the seed value of 1729384 and hit go. All right, so we have that. Perfect. Now let's go ahead and grab this seed value of 4710983. Paste that into our seed of the KSampler and hit go. And again, all of these images, now that I'm using the save image node, well, this is going to go into my assets that I can see later. So now that's our butterfly here. Again, no other values that I'm changing except for the seed. And now let's try take C, and we're going to use 8821055. Hit enter and go. And again, a different butterfly. Same prompt, same steps, same CFG guidance, same scheduler, same denoiser, all of that stuff. Just changing the noise pattern on top of our latent image that we're allowing to come through. So let's go ahead and go over to our asset folder. And as you can see here, all the different takes that we've just done. This was I'm not going to remember those seed values, but this was the first seed value. This was the second seed value, and this was the third seed value. Again, you can see they're very, very similar because we're guiding it with that underpainting, essentially, with that empty latent image, no longer being empty, but now filled with the picture of an example butterfly. And we're just changing the noise pattern. So very similar. They almost feel related, don't they? And I like to, again, really use this as the preview image node for iteration. And then when I get to the point where I want to start saving things, I want my keeper pile, well, I'm going to use the save node. And then it gets it all stored in your asset folder. So another really cool thing about these assets in your asset folder is those images, beyond also being images, are also your workflow. It contains the recipe, the graph that you just used to generate that image, all in that one thing. Go back into our assets folder over here, and we're going to hover over this one, the middle one, and go over to those three dots over there, and you have now a few different options. You can inspect the asset, just means look at it. You can insert it as a node in your workflow, automatically insert it as a load image. You can download it, of course, or you can open as workflow in your new tab. And if you do that, well, let's pop this open. And now this again is the exact same workflow that we use with the exact same seed all locked in there. So this is a really nice way to pass around your work along with your JSON file. And it also demonstrates a concept of your asset library becoming your, well, over time, that input folder becomes this creative kit. It contains all the workflows that you use quite often. So treat it like one. Keep it organized. I am not always. I'm always guilty of having not an organized asset library. I try to do it, but be better than me. Keep a nice organized asset library because I promise you, it really does help. Because now these become your tools in your toolbox. So really keep your asset library nice and clean. Don't just generate into it over and over again. Again, just personal advice using it. Really try to keep it nice and organized. Don't treat it like a trash bin. Now for the next 15 minutes, which means I want you to pause. That's right. I want you to pause this training video. I want you to drive. I want you to build a text to image workflow from scratch. I want you to generate some takes again using that preview image node, not the save image node yet. But I want you to, same prompt, but different seeds, maybe different, schedulers, different, play around with stuff. This is all about play. You can't break this. Go ahead and just start pushing around the knobs and see what happens, because that's the best way to learn in Comfy is to play with it. Then after you get your text to image feet underneath you, then I want you to pick an image of your own and convert that workflow to an image to image workflow. Then after you're done, I want you to show yourself how to grab your assets and then save that image and then open it up as the workflow. You've now saved the image and the workflow. Maybe send it to a friend and tell them how awesome Comfy is. And hey, check out this this image I just made. It's awesome. Mine's a butterfly. What's yours going to be? But you can pass that workflow along with the image, and then they can play with it as well. So that's going to be your exercise for a little bit. So why don't you go on in and play around, and then we'll come back. So as you were making your images, I hope you didn't have any trouble, but inevitably, working in Comfy, working in any software at all, you're going to have troubles. You're going to have things that break. So in this part of this core skill module, I want to talk about troubleshooting and debugging because things will break. And as an artist, the sooner that you kind of become comfortable with learning how to get around those roadblocks and learning what these errors mean and how to fix them, well, you're going to learn pretty quickly that they're a part of the process, and it's not a failure of you. It is it's all about just being an artist working in Comfy. So let's go ahead and dive in and talk a little bit about that. So one of the things I want you to do is whenever you get an error, again, it'll pop up over here and you'll see a big failed thing over here, right? So these have all failed and with no error message because I just killed it. I didn't care about it, right? But they will usually give you a big long report underneath there, and it's going to tell you why it failed. And again, when you're first seeing these errors, I know I felt like, what did I do wrong? Oh no, Comfy's yelling at me, right? Well, it's not a punishment, it's a hint. And I want you to read it like a sentence because read top to bottom before going in and just start changing anything, trying to fix it. Because what you're going to see there is it's going to try to help you understand it. And a really good trick whenever you're working with Comfy and you see these error messages from these AI models that are breaking, well, use AI to decode it. Go ahead and copy that error message, literally paste it into your favorite LLM of choice, Claude, ChatGPT, whatever. All of them know Comfy very, very well and can help you debug and say, ooh, I know what's wrong here. So that's a really good way to kind of get unblocked pretty quickly. But again, it's also important for you to start understanding what those common errors are. So read it. Comfy will highlight the node that broke in red as well. It'll be a big red square around it. And it will give you error names of like the input that failed. So if the model was failing, and then just try to find it in the graph. And then the error is going to tell you what came through instead. And the gap, the fix is always the gap between 0, 2 and 0, 3. Something in the middle there broke. So look for those breakpoints. And another good way to debug these things as well is by using the bypass. Go ahead and before I try to rewire anything. I go in and I just start disabling nodes. Say if maybe my KSampler is custom and it broke. Maybe I'm using a custom clip text, something like that. Example after example. Just go ahead and highlight the node. I would never bypass a VAE encode. It's essential, but just go ahead and click it, Control B, and now it's bypassed, and it's not going to process any information that's going through that. Again, it becomes a breakpoint. So you kind of move around those graphs, and it helps you kind of get your head around it, because this is a very simple workflow, but some workflows, obviously, as you've probably seen, can be extremely complex. So that's how I go through it, very systematically, and just try to find the breakpoints, bypass it, and see if that fixes it. Because usually that helps you not make your final image, but it sees where the issue really is, and can kind of give you a hint, a direction of what you need to do to fix it. Now, here are 6 failures that you'll see. Well, I hope not weekly, but you'll see a lot, and I think you'll start noticing the pattern. These are pretty much the most common issues that will break Comfy. So I just want to dive in real quick and talk about each one and explain why they break. So the first failure that's very common is wrong model. You could have an SDXL graph loaded into a model a graph that's trying to use SD 1.5. So you got to match the family. Every node in a branch should target the exact same model architecture, and every model has its own needs and wants. So when you start mixing these families together, well, they're not going to all get along, right? that's just how it goes sometimes. So you need to make sure that if you're, for example, we're going to be talking about LoRa's in just a little bit. If you are using a LoRa that was trained in Stable Diffusion 1.5, but you're using it to modify a model that is SDXL, well, it's going to break and not know what to do. So make sure you match all the archetypes. Same thing goes for those models that have different VAE or clip models that come into it. The nice thing about checkpoints is you can make sure that it's all the same family of different models working together. But some workflows will have, again, those broken out off to the sides. So make sure that they're all from the same family tree. Type mismatch is another one as well. We saw that. We prevented that before it even happened. But if we tried to wire an image into a latent socket of that KSampler, well, it's not even going to let us do it. That's where we then need to add a VAE encode, because we got to make it to the same type of information that the sampler is expecting to need in order to wire it up. Another common error is just missing an input. Maybe you forgot to connect something. Maybe you didn't give the VAE encode the VAE data from the base model, and it's just going to error out and highlight red. Let's go ahead and do that real quick, and I'll show you. So let's disconnect there, and you'll see it scream at us really, really quick when we try to hit save image. And there we go. Required input is missing. Let's see errors. And when we click that, we then have this errors workflow menu over here. Again, it's just this little sidebar over there. Highlighted in red. Again, red is bad. So you have VAE decode, and now it's telling you what it needs. Required input is missing, VAE. So now we know, oops, what did I do? Go ahead and connect that in there and connect that back. And now we have a happy graph if it lets me connect into there. Yep, there we go. Perfect. Now all of our errors are gone. Another common error, not when you're working in Comfy Cloud, because you have access in Comfy Cloud to some extremely powerful GPUs, like 6,000 Blackwells, things like that. things with 96 gigabytes of VRAM, so much VRAM. But if you're working on your desktop and you don't have, a super powered Blackwell 6000 there with a ton of VRAM, and you have a really hungry model, well, you're going to run out of memory pretty quickly. So there are ways to get around that. One of them is dropping your image resolution down. Maybe that's going to help free up a lot of VRAM as well. Maybe pick a model that is not as hungry, that can exist on 16 gigabytes or 32 gigabytes of VRAM. 32 gigabytes is usually more than enough for most of the stuff that you're doing in Comfy. But again, that's the common error. Out of memory, and it's just going to yell at you CUDA errors. So that's what that means. Another common error is, of course, just a bad path. A node is pointing to a file that doesn't exist. Maybe you inherited a workflow that has a path to a model that you don't have personally loaded on your machine. Well, it's gonna break, and it's gonna say, "I don't know where that is," so that'll break it. Another thing that can happen is, again, this happens because Comfy is open source and it has a amazing creator community behind it, constantly developing new nodes for different models. But sometimes the model gets updated, but the custom node for that model does not get updated. Say you have a custom KSampler for LTX, something like that, right? Well, that custom node might break because it's out of date. So ways to get around that are make sure you update it. There's probably a new version out. If there's not, you're gonna have to wait for one. But maybe somebody else made one, so you can just replace it. Those are gonna the things that are gonna be a common that you're gonna see break a lot, because Comfy is constantly getting updated. The models are constantly getting updated, and everything kind of needs to follow in the same lockstep with each other. So outdated nodes will cause errors as well. Another thing that can be frustrating sometimes when you're working in Comfy Cloud, you won't notice this much if you're working in Comfy Desktop, but we saw it already, right? We had a job that was hanging. Every job runs in a queue. It all gets in line and it waits for its turn to run on the data center that has all of the different GPUs that Comfy Cloud gives you access to. So you're waiting in line, and sometimes you'll get stuck. So for one thing, one reason after the other. So again, I do the 10-second rule. I'm just kind of waiting in line, and if it's for 10 seconds and it doesn't hit that, it doesn't take flight, it doesn't start running, I'll just kill it and start it over again. The worst thing to do is keep spamming and just keep run. You're just going to see your queue stack up, and then you're going to have a ton of different generations that you don't need, and it's going to get very confusing. So I hit it one at a time, check it, and if it gets stuck, kill it, and then start it again, and it picks up pretty quickly. And if your job fails, well, instead of queuing a whole bunch of them at the same time because you're frustrated, well, you can just click on that failed job, inspect it using that little sidebar over there, and see what the error was. Again, read it like a sentence. It's giving you hints, and Comfy's trying to help you. And another thing to keep taped to your monitor, I think by the end of this, you're going to have a ton of sticky notes all over your machine. But everything is data flowing through a system. Think Comfy like that. So when we're looking at a workflow like this, well, all the data is coming from this checkpoint, and then it's getting infused with some new data, which is our prompt, our positive and negative of a butterfly and what we don't want. Then we're giving it more data, which is the underpainting. This is given in both a structure for what the image that we want to generate is, as well as the size of the image. So it's all data flowing from left to right, top to bottom, whatever direction you like. But think of a workflow like that. It's kind of like water. It's flowing all through, and all the pipes have to connect, and no clogs. And again, errors are part of the process. It's okay. It's not a failure on you. The worst thing you can do is feel like you are failing. You've broken something, especially when you are getting started. It's going to be so discouraging. And like it says here, every senior artist has seen that same red node 1,000 times. So just don't worry about it. see it like for what it is. It's just a bump in the road. It's giving you information about what's broken. And you have some skills here of how to debug those errors. But don't get frustrated. It's all a part of the process of working in Comfy. Now, this is a really fun exercise. I want you to practice breaking things. I want you to go in there. I want you to disconnect required input and try running it. I want you to then read the error out loud. Literally, I will check out the error and I will read it. When it's really a lot of code, you'll sound crazy, and it's just all gobbledygook. But it really helps you kind of verbalize and then start figuring out what that error is trying to tell you. Just gives us some structure. It's just a quirk of the human brain, I found. Reconnect and rerun. Once you fixed it, rerun it. You disconnected that required input. Well, now reconnect it. And then I want you to swap to an incompatible model. Um, uh, this is a hunt. I want you to find a model that doesn't include VAE or clip. And you have to load those different models in there and connect it the same way. But why don't you try to find a model that is SDXL, and then you try to load in a clip that is for SD 1.5, like we've been talking about. See what happens. Again, it's a model mismatch, and then fix it. So this will be fun. It's all about breaking things. I find it kind of a cathartic experience working in Comfy like this. So, but you're going to really sharpen your debug skills, which before we get really, really deep into Comfy is another core thing that you've got to get really good at, which is just debugging Comfy. It feels daunting at first, but the best way to get good at it is just by doing it. So go ahead and pull all the wires, break everything, and then reconnect it. And I'll see you all for the next module where we'll take it up a notch and we're going to start talking about LoRa's and control nets. All right, I'll see you in a bit.